Here I am going to show you a problem related to operational amplifier comparator circuit. There is nothing special about this circuit. I was asked to make a separate video with the problem of operational amplifier comparator. That's why I am making this video. Okay, let me read out the problem. An operational amplifier is biased with plus 12 volt and minus 12 volt. You know that an operational amplifier needs two bias voltage. Here the positive bias voltage Vs is plus 12 volt and negative bias voltage minus Vs is minus 12 volt. Now a triangular waveform with 5 volt peak, a triangular, let's say this is a triangular waveform. It has a peak of 5 volt and this kind of triangular waveform is applied at the inverting terminal of operational amplifier and a voltage of minus 1 volt, and that voltage is DC volt, is applied to the non-inverting terminal. Draw the relevant circuit diagram, input and output waveform and transfer characteristics of this operational amplifier. At first you have to know that when an operational amplifier acts as a comparator circuit, it will contain two voltages. One is input voltage Vi and another is a reference voltage Vref. When this reference voltage is equal to 0, then the operational amplifier acts as zero crossing detector. When the reference voltage is equal to 0, the output voltage will have a transition from either positive to negative or negative to positive saturation level when this input voltage crosses the zero axis. If this reference voltage is set as positive, then our operational amplifier will operate as positive level detector circuit, and when this reference voltage is set to negative, then the operational amplifier will construct a negative level detector circuit by indicating a transition in the output voltage when the input voltage crosses the negative reference voltage. Okay, now let me draw the relevant circuit diagram. As here input voltage is this triangular waveform with peak plus 5 and minus 5 and the reference voltage is minus 1 volt. That means this problem is dealing with the inverting. See here the input voltage is applied to the inverting terminal, so the circuit will form an inverting negative level detector circuit, and that circuit will look like this circuit. Now let me configure the circuit with the given parameters. Here we are applying the positive bias voltage plus 12, negative bias voltage minus 12, input voltage with 5 volt peak, and the reference voltage is minus 1 volt. See, when the reference voltage is negative, this negative terminal will be in upper side and the positive terminal will be at lower side, and this is a DC source. We are supplying minus 1 volt with a DC voltage source. Now we are applying triangular waveform. So now let me show you the input and output waveform and the transfer characteristics of operational amplifier. This is our input waveform. This is a triangular wave shape. This is t equal to 0. It has a peak value of plus 5 and negative peak of minus 5. Okay, see, this is our input voltage Vi. As this is our t equal to, this is our 0 axis as our negative reference voltage, then our Vref will be equal to minus 1. Now if you recall the operation of a negative inverting negative level detector circuit, you will see that in that circuit when our input voltage Vi is greater than our reference voltage, our voltage difference will be negative, and when this voltage difference is multiplied with our high gain A, our operational amplifier will operate in the negative saturation region. And when this input voltage is less than reference voltage, our voltage difference will be positive and our output voltage will be plus V set. And as I have told you earlier that our negative saturation voltage will be nearly equal to negative bias voltage, and here we are applying bias voltage, negative bias voltage 12 volt, and our negative saturation voltage will be 1 volt lesser than the bias voltage, and our positive bias voltage is plus 12 volt, and saturation voltage will be tends to plus Vs, and it will be plus 11 volt. That means 1 volt lesser than the positive bias voltage Vs. Now input voltage is greater up to the interval in which the input voltage will be greater than our negative reference voltage, our operational amplifier will give a output of minus 11 volt, and as long our input voltage will be less than the reference voltage, that means input voltage will be more negative than the negative reference voltage, our operational amplifier will be in positive saturation and it will give us a value of plus 11 volt. Now consider this point to this point. It is obvious that within this interval our input voltage is greater than our reference, this negative reference voltage. That means our output voltage will be in negative saturation, and our negative saturation voltage minus V set will be nearly equal to our negative bias voltage. Now from this point to this point our output voltage will be in positive saturation, because see, as this is our input voltage Vi, and in this interval our input voltage is less than our reference voltage. As a result our output voltage will be plus V set plus V set nearly equal to 11 volt. Okay, now from this point to this point output will be negative saturation, and after that output will be positive saturation. This is our input and this is our output waveform. Now I will show you the transfer characteristics. Transfer characteristics implies how the input will affect the change in the output voltage. Here we are supplying our negative reference voltage VREF equal to minus 1. The points that are lying in the right side from this negative 1 volt, that means in this region obviously our input voltage Vi is greater than VREF, and as long our input voltage is greater than our reference voltage, our output voltage will be in negative saturation. That means this, if this is our output voltage, it will be minus V set. Now the points that are lying in the left side from this point, it is clear that our input voltage Vi is less than or more negative than our reference voltage, then our output voltage will be in positive saturation and it will be plus V set, and our plus V set will be controlled by our positive bias voltage, so it will be 1 volt less than our plus Vs. Okay, that's it. Thank you.